This is the solution of Waterloo University math competition for the secondary school students. So this is for grade 9, and the name is Pascal contest in 2022. So now I will solve the questions from number 11. If you have any questions about my solution or the between from number 1 to 10, please feel free to make any comment on this video. So let's go to number 11. But before we go, actually we can use calculating device. So sometimes I may calculate on my side. So during that time you can also try to do that. So number 11, this is part B. So here in the diagram PQRS intersections, so perimeter of parallelogram PQRS. So this and this is easy. This is 3 and 3. The problem is PQ because this is the hypotenuse of the right triangle. So now let's make it the right triangle here to define, to calculate the length of the hypotenuse. So this is a 3 and this is 4 and this is 5. If you remember this Pythagorean number, which is a 3, 4, and 5, is very good because you can reduce the time to calculate. But you need to understand the 5 should be the hypotenuse. If you have 3 and 5 here, for example, this is a totally different question. You need to calculate it. So now we have 3 and 3 and 5 and 5. So altogether, 16. How many of the integers from 1 to 100 inclusive? One list, one digit equal to 6. Then we can think like only 1 6, 1 6, or like 2 6, or 3. We cannot have any 3 6. So actually 2 6s also we have only 66. There's no more we can have because this is until 100. So now we have only 1 6. If it is one digit, we have only 1. And 16, 26, 36, blah, 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 exclude the 66 and until 96. So here, 1, 2, 3, 4, 5, 7, 8, 9, and 0, 6. So we have 9 of this 1, 6 on the last digit. So this is like now we have this one. Only here we have 6. This is we have 9 cases. But if you have 6 here, let's say 60, 61, 62, then from 60 to 69 we have 10 numbers, but we need to exclude the 66 because we count there. So this is also 9 numbers. So now we all together have, this is 1 numbers. So 19 numbers. Maya, Rosie, 90 meters apart. They're starting at the same time, run toward to each other. So Maya, Rosie. Maya runs twice as fast as Rosie. How far? Maya run when they meet. If you remember the formula of the time and distance and speed, then it's gonna be helpful for you. So now Maya has twice faster than the Rosie's speed. So Maya has double speed than Rosie, which and the time is constant because they meet. They start at the same time and they meet at the same time, which we have same time for both of them. So the distance is speed times time. So speed is 2s n time t. This is s n time t. So the distance is 2 st, here st, which is, this is longer, like a double, than the distance of Rosie runs. So this was 90 meters apart, so this is like from here 60, from here 30. So Maya run 60 meters when they meet. Number 14, Dhruv is older than Bev, so Dhruv is here and Bev is here. So this is, let's say, ascending. Bev is older than Elsim, so Elsim is here. So Elsim is younger than Andy. Andy is younger than Bev, so Andy will be here. And Bev is younger than Cow. But it doesn't, we have no clue of the relation between Cow and Dhruv. So Cow can be here or here. So wherever he is, actually it doesn't matter because it is asking about who is the third oldest. If he's here, still third is Bev. Even he was here, then still third is Bev. So the answer is Bev. Number 15. How many of the integers can be expressed as the sum of two prime numbers? So for example, sorry, other than number 2, all prime numbers are odd number. But those are already odds. So, you know, when we add odd and odd together, for example, 1 plus 3, it becomes an even number. But all of them are odd already, which means we can add 2 plus something. So this can be 2 plus 17 only. We cannot say 3 plus 16 because 16 is an even number, which is not prime number. Only 2 is the even and prime number. This is 2 plus 19, 2 plus 21, 2 plus 23, 2 plus 25. So here we can find this, and this can be expressed as the sum of two prime numbers. So we have 3. Alvin, Bingi, Cheska, 2 players. Tournament between 2 players, a total of 60 games are played, and each pair of players play the same number of games. Okay, so this is a tournament, and maybe A and B, or B and C, or C and A. So each of them 20 games. So 20 games, 20 games. So altogether 60 games. So Alvin and Bingi played. Alvin won 20% of the game. So the probability of winning for Alvin for this game is 20%, which is 80% of winning probability for Bingi. And here Bingi has 60% and 40%. Okay. Yeah, I just confused. What if they tie? But anyway, there was the condition, they never ends in a tie. So now Cheska won 40% and Arvin 60%. So the question is, how many games did the Bingi win? So Bingi have here and here only. So during 20 games of the first pairs, he is winning 80%. And the second set, B and C, among 20 games, he is winning 60%. So 16 plus 12, 28. Integer A, B, and C satisfy the equation. This one and value of B is something. So now we want to know value of B. So we will leave B and we substitute all other variables into B. So for example, A should be expressed with the variable B, so B minus 5. C already here, 5 plus B. So we can put it here. So B plus 5 plus B equals B minus 5. So B is negative 10. Number 18. This is like game. We perform the sequence, the steps. So the first two steps, rightmost ball, which is 5, picked up and put it in the middle here, and 3 and 4 goes there. Okay, and the second step, leftmost ball picked up and put it in the middle here. Sorry. So it comes from here. So 1 comes to here, and 2 and 5 goes there. So this is repeated and keep going like right and left and right and left. So immediately after step N, the balls are in the reverse of their original order. The numbers are so big. I mean, how can we make the trial of 2020, for example? So in this type of question, it is asking us to find the pattern. So, but at this moment, actually, we don't know the patterns. So let's go a little bit further. So this was the rightmost, this was the leftmost. So let's go another like moving of the rightmost, the number. So 4 comes here, and 1 and 3 goes there, 2 and 5 stays there. And let me put it here. And left 2 goes there, 5 and 4 here, 1 and 3 there. So 3 comes here. Oh, we've already reached it. Oh, I said we need to make like this 2,000 steps. But we've already reached this descending order, like reverse order from start, in 1, 2, 3, 4, 5 steps. So whenever we continue 5 steps, we keep making the numbers reverse. So it should be the multiple of 5. But between 2020 and 2025, okay, because now we make it reverse. But if we go further 5 times, it will go back to the number sequence of the start order. So which means we need to like 5 reverse, 10 the original, 5 reverse, 10 original, something like that. So it should be the number 5 for the last digit. Number 19, Miyuki texted a 6-digit integer. So it is a 6-digit. And there are 2 S's, but it doesn't show, and it just went as a 2022. So number of possible 6-digit integers that Miyuki could have texted this. So we can find just a possible position for the number 3s. So 2, 0, 2, 2. So here, 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 here. So let's say here and here, or here and here, here and here, here and here. This is 4. And here and here, here and here, here and here, 3. And here and here, here and here, 2. And the last one, here, oh, so here and here, plus 1. So all together, 10. A pizza is cut into 10 pieces. 12 pieces are 1/24 of whole size. So 2 are 1 over 24. 4, 1 over 12. Just to be safe side, let me make it 2 over 24. And 2 are each 1 over 8, so 2, but 3 over 24. And 2 each, like a 4 over 24. So altogether is this compares 1, so 24, 2, 8, 6, 8. Okay, so this make it. So now we will share the pizza with friends, and there are n friends altogether, and they have equal amount of pizza. And we don't cut any further, we don't make any smaller pieces out of here. So how can we share this? Let's do that. Because this is like, the denominator is a 24, so the distribution should be happened within the factors of 24. For example, we cannot distribute to 5 friends. How can we distribute this 20, just 1 over 24, maybe this is smallest unit? How can we make, like, distribute to 5 friends with 24 denominator? So I guess between 2 to 10, we can consider 2, 3, 4, 6, 8, something like that. So if there are 2 friends, actually it's possible because just we can distribute half and half, so it's no problem. So this is valid. So if it is a 3, because now we have 20 over 24, so we need to distribute 8 over 24. So for example, one person has 2 of this, which is 8 over 24, and the next friend have 2, like a 6 over 24, and 1 from here. Then we have 3, so 6 and 8. So this is also possible. And 4, which means we need to distribute like amount of 6 over 24. 6, let's say 1 person can have this one, and 2 person can have this one. So 6 over 24, but this can be 2. So now, so 4 over 24 plus 2 over 24 times 2, we can make a 2 over this set. And we still have a 2 here, and we can distribute it like that. So this is also possible. What about number 6? If it is number 6, then we need to distribute 4 over 24. So 2 can have this, and like this, 1 and 1, and 2 of this. So this is also possible. And number 8, if we are 8 altogether, then we need to distribute 3 over 24. Oh, this is not possible because we already have the largest size is 4 over 24. So we need to cut it, but it says we don't cut it. So 2, 3, 4, 6 is the valid number. I think you can memorize this one just to be fun. So the number from 1 to 10, if you add all the numbers, then it becomes 55. But this comes from 2, which is not from 1. So here, whole number, if we add them together, it is 54. But we need to exclude all of this, which is 15. It goes to 39. So let's go to part C. So number 21. This is pegboard, 5 by 5 centimeter by 5 centimeter, 10 by 10, but it shows only one. Intersection of invisible horizontal and vertical lines. 1 centimeter interval. So this and this, each of them 1 centimeter. So this is 5 by 5 then. And 10 by 10 doesn't show here. So pegs are placed into the holes on the two main diagonals on like this. So it has altogether 16 holes, but now it has 8 holes with pegs. So 8 is emptied one, unshaded one. So we need to make a 10 by 10. Okay. I think 10 by 10 should like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, let's say. Then we need to make the grid 9 by 9. 3, 4, 5, 6, 7, 8, 9. Yeah, I need to make it larger. For example, like this. 4, 5, 6, 7, 8, 9. Like this. Like this. And we will put pegs like here and here. And we need to count the emptied holes here. So altogether 9 by 9, there was 81 holes, and the diagonal has still 9. And here 9. But it's a little bit different than here because this has even number and even number, so there was no intersection at the center. But now we have 9 and 9, so this fifths and fifths, there is the like intersection shared point. So this one is counting from here and here both, so we need to take out 1. So 17, 4, 64 is the answer. So what is the integer formed by the rightmost 2 digit? Rightmost is like unit and tens, so equal to, oh, okay. If it is only last digit, it could be quite easy because always they have their own pattern. But still, we need to find the pattern because we cannot just make them like multiply them 127 times, something like that. So let's find the pattern about 4. So now we need to find the pattern for the last 2 digits. We don't much care about others. So let's say 4 times 1, 4 to the power of 1 is just 4. Let's say 04. And 16, 64, 4, what is that? No, I made a mistake. 56 and 4, and 4, and 4, oh, we still couldn't find the pattern. And 4, am I right? Just let me use the calculator. So this is the one, wait. Let me open the calculator. So I don't much care about other numbers, only last digit. So 4 by 4 by 4, 64, 56, 24, 96, 84, 36, 44, 76, 04. Finally, we have 04. So now this pattern is repeats within 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So every 10 has its own pattern. So now we need to find the sevens because 120 already reached the 76. So we need to go further for the 7 more times. So 1, 2, 3, 4, 5, 6, 7. So last digit could be 84. And what about 5? 5, 25, 125, 25, 625, 25. Oh, this is always 25. Oh, this is always 25. Thank you. And 7, 49. Let me do with the calculator. So 49, 7, 43, 01 times 7, 07. Okay, so now we already found the pattern. This is every 4 has its own pattern. So 131 is 128 plus 3, which is we have this full cycle many times, and another 3. So 1, 2, 3. So this should be 43. So when we add them all together, still we need only last digit. So 84, 25, 43, 52. So number 23. In the diagram, 2 circles and centered at 0. Smaller circle radius 1 and larger one is radius 3. PQ. Okay, so these are 2 shaded regions. If we POQ here X, then here 360 minus X. So let's say here number 1, number 2. Let's say the area of number 1, pi r squared times 360 minus x over 360 equals pi r squares times x over 360 minus, because it doesn't include this smaller sector, pi r squared x over 360. Let's all make them multiply them 300 over pi on every terms. So now we have 360 minus x equals 9x minus x. So x is 40. And number 24, pretty number. Name is pretty. So pretty number is the 7-digit positive integer with the following properties. Leftmost 3 digits are perfect squares. And rightmost 4 digits, perfect cube. So these 3 numbers are perfect square. And here, perfect cube. So we need to find the 3-digit perfect square numbers and 4-digit perfect cube number. So there are more conditions. 10,000 digit, which is here, and 1 digit, unit digit here. So they should be equal. And thousands digit is not 0. Okay, so which means it should be the 4-digit perfect cube. So let's try to make it. But how many numbers have the squares of 3-digit numbers? So 30 by 30, 900. Let's say 31 times 31, 961, 32 times 32. 1024. So from 10 to 31, this has the 3-digit perfect square numbers. What about cube? Let's say from 10 to 20 is already 8,000. Let's say 22 times 22 times 22. Oh, this is already finished. 21 is 9,261. So 21. So this is just for me to understand. So I will make the perfect digit number for here with these numbers, and perfect cube for here with these numbers. But anyway, we need to find the numbers whose matches the last digit. So let's categorize them with the last digit of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, let's say. So let's say 10 squared, last digit is 0. 11 and 12 squared. 13, 14, 15, 16, 17, 18, 19, 20. So let's say like this. And 21, 22, let me do it here. 21, 20, what? No, not 21 there. So 22, 21, 29, 22, 28, 25, 24, 26, because it's the last digit, 23, 27, and 30, and 31. So this is the, we like separate them along the last digit number. So this was the square number, like first 3 digits. So let's go for the last 4 digits. So 10 cube, 10, 10, 10, so 10 cube. 11, 12, like 2, 2, 2, 8. And 13, 3, 3, 3, 7. 14, 4, 4, 4, 4. And 5, 6, 7, 9, 3, 8, 4, 2, 9, 1, 9, and 10, like which is 20, and 21. So this is how we can make the last digit. So here, if we have 100 here, then we can have 1,000 here, for example. But not only 1,000, 8,000 here too. So all of those like satisfies the condition. So now how many pretty numbers are there? So here we can select any of these for the first 3 digits to make the last digit 0. So 3 times 2, we can choose any of these, plus 5 times 2, plus 4 times 1, plus 2 times 1, plus 4 times 1, plus 4 times 1. So 6, 10, 4, 2, 4, 4, 10, 20, 30. So maybe there are 30 pretty numbers for this 7-digit positive pretty numbers. And number 25. Oh, the questions are quite tough. Hexagonal prism has a height of 165. 2 hexagonal faces are regular hexagons with a size of length 30. So each of them are 30. And this is regular hexagon. Okay, so point X, there are fly and ant. And fly flies directly along the shortest route through the prism. So through the prism. So maybe it reaches like the inside of the prism. And curves around the outside of the prism along the fast constant slope. It wins around the prism exactly m plus a half times. Distance crawled by the ant is more than 20 times the distance flown by the fly. Okay. So let's calculate the fly trajectory length. So from here and there, when we see this hexagon like here, you know this, if this is 30, then this is 30. This is a right triangle, which is the like a special angle case because this is 60 and this is 30. The regular hexagon always very close to the equilateral triangle. So if you are so confused, or if you are struggling to approach the question with regular hexagon, most of the answer comes with regular, what is that? Equilateral triangle. So that this is the 30, and this is the special angles ratio. Here x is square root 3, this is 2x. So now we have 2x, it's 30. So here, this should be 15, and this is 15 square root 3. So here, this is 30 square root 3. So that was 50 square root 3, this altogether 30 square root 3 like this. So the fly, let's just forget the base shape of this hexagon for fly because he just fly over directly from here. So this is 30. But now, just now we found this is 30 square root 3. And this is 165. And fly comes from here to there directly, like this diagonal. So when we have it, it is this, the cuboid diagonals has the formula of each of the size length squares, and we add them together and make the square root. So 30 squares, 30 square root to 3 squares, 165 squares. So this is for the fly. So now we need to calculate the ant trajectories. So if we expand them like this, that one, the 6 times, 1, 2, 3, 4, 5, 6. This is 1, like 1 times. But if it has 1 times, but this is 180 centimeters. Because it says n times, so 180 times n plus half times means 90. So ant goes like this, 165, and here 180n plus 90. So if we calculate it with the Pythagorean theorem, squared plus 165 squared. So this is more than 20 times of 30 squared, 30 squared to 3, 165 squared. So let's calculate it. So here, just to make it 180n plus 90 squares plus 165 squared. I'll make them squares on both sides. So 430 squared, 30 squared, 3 times 30 squared plus 165 squares. So let me calculate it with the calculator. So 430 squares times plus 165 squares plus 165 squares. And this is 12357,225. So I'll make the square root to find 180n plus 90. So square root here. N minus 90 n over 180. So when I calculate this inequality, n is larger than 19.029 blah blah blah. So therefore, smallest possible value of n is 20.